Now let's talk about some slightly more complicated data structures. And these data structures are sometimes called composite data structures because they are essentially large containers that can contain other containers. So now let's create a new file. So by default, it's going to be named as untitled1.py. We can try to save it as a different name. Let's just call it hos2.py, and hold down the command key, and the plus sign is gonna blow up the fonts inside the editor, so it's easier to see what's. I'm switching the tab to Variable Explorer, and I am inside the IPython console. So what we are going to talk about today is composite data structures, right? The first composite data type we will be talking about in detail is the so-called list. And in Python, this list has similarities to the array data structure used in other languages. But in Python, this list data structure is by default dynamic, and it can be used in several different ways. So in order to use a list, we need to define it first, right? Defining a list. So how do we actually define a list, right? So here's an example. I'm defining a list called countries, and I must use square brackets. And inside of these square brackets, I can type up some strings. And I can run it. Now I have in the variable list, in the variable explorer, I have the name called countries. The type is a list. So list is an inherent data structure, is an inherent data type for inside of Python. So if you do in the console, if you do type countries, then it's going to tell you it's a list, right? So a list is just like a int, a float, a string, or a some other data type that's built into the Python language itself. So a list is a internal data structure. There are some things that we have to pay attention to. First, it's the square bracket, right? It's not any other bracket. It's not the parenthesis, right? And a parenthesis is actually used for another data structure that's called a tuple, right? Which we will talk about later on. A tuple is basically just an immutable list. But here, if you want to use a list, it must be a square bracket, a period of square bracket. Another thing that every element inside of the list has to be separated by using a comma. This white space is sort of optional, but this comma must be there. Otherwise, it's not gonna give you the desired results. So suppose we do something like that. Countries 1 equals to USA with just a white space. Canada, Mexico, India. Oh, sorry. With just a white space, right? Nothing else. Then what's gonna happen, right? Suppose we run it. Then countries 1 is gonna be a list with just one element in it, and all the strings are being concatenated into like a one string. So there's no separation on it. So this is actually an incorrect code. This is the incorrect code. Right? It doesn't give us the desired results. Right? It gives us a concatenation of strings instead of a list of strings. And that's for strings, right? Suppose it's numbers, right? Suppose it's numbers 1, 2, 3, 4. That's gonna work. This is gonna work, right? Numbers 1, 2, 3, 4. Right? But if you get rid of the comma, then it's gonna give you a syntax error. Invalid syntax. It's telling you it's a syntax error, and the editor is also telling you invalid syntax. Right? If you are a MATLAB user, you might be kind of used to this kind of a specification for vectors or matrices. And again, this is syntax error in Python. It doesn't recognize it. Right? So this is also incorrect code. So both lines are actually incorrect code. So let's get rid of it. And the elements inside the list do not have to be of the same data type. We can actually mix different data types. For example, we can create a list with the name of the country as a string followed by an integer for the population of that country in millions. So countries and population equals 2. So here I'm using snake case. So variables can use underscore in their names. Right? We haven't talked about the naming convention in Python yet, but one of the naming conventions is that any kind of variable can, the variable name can be composed of letters and underscore and also numbers. Right? But you cannot start a name with a number. You have to start a name with either underscore or a character or a letter Right? And usually variables are named like small case words separated using underscores. Right? If you want to capitalize, camel case are usually used to represent class names. Right? We'll talk about classes when we talk about object-oriented programming in Python, and classes are named using camel case. So here, countries and populations, we will use a mixture of strings and numbers. Right. Canada, 6, Mexico, 127, India, and if you run it, we're going to get a new list, countries and the population. Right? So Python actually recognizes this kind of mixture of different data types. So that's for creating or defining a list. Right? So now let's look at how do we actually accessing the elements that's inside of a list. So a list is essentially just a sequence of ordered smaller containers, with each container having a unique integer ID assigned to it. And we can use this integer ID to retrieve the content that's stored inside of each smaller container. And this integer ID sometimes is called a position, the position inside of a list. It starts, so the first container inside of a list has the integer ID of 0. So if we want to access the content inside of it, we can use the name of the list followed by a pair of square brackets with the number 0 inside of it. So suppose we want to print countries. If we want to print the content of the first element, then it's countries, square bracket, 0. 0 is the position number. It actually is going to access the content inside of the first container of the list countries. Right, so index actually starts at 0. It's not starting at 1. So if I run it, it's going to print USA. That's the first element inside of the countries list here, right? It is kind of very important to actually pay attention to the first index. It is not 1 but 0. If you have used C or C++ or Java before, this 0-based index convention in Python is actually consistent with those languages. But if you are a MATLAB user or a Fortran user, like Fortran 77, that kind of, this is actually an important difference, because in MATLAB, the first index is always 1. It's not 0. Right? The first index of any kind of matrix or vectors in MATLAB is always 1. But here in Python, it actually starts with 0. So once we have retrieved the content from one container, and we can call the methods defined on that container, defined on that content, the content. So here, the data type of the content is a string, right? So we can call the upper method to convert every character to uppercase. So suppose we print countries, right? So this time let's not use the first element, but use the second element. The second element is going to have a position ID or index 1, right? This time upper, I'm calling the upper method. This is the second. Right. The reason that I can call this dot upper, this method, is because countries 1, square bracket 1, actually returns a string. And on string, you have this kind of a dot upper defined, right? So let's print again. So now it's printing Canada, but with all uppercase, right? But inside of the original list, the second element actually has title case, right? Canada, C is capitalized, but everything else is like a small case. But now it's been turned into uppercase for all the characters. So we have, for this particular list of countries, we have 4 elements inside it. So the last small container inside of it has an index of 3, not 4. In 0-based index, the last index is always the length of the list subtract 1. So if we want to get to the last element, countries, it's 3. The last element has an index of 3. So this is 0, this is 1, 2, and the last one is 3. Right? So suppose we actually want to convert it into a lowercase, right? But it's already in lowercase, it doesn't really matter. So, but that's the last element. So now you should print India in lowercase. So sometimes especially inside of a big program, we may not sort of know immediately how many elements are inside of a list, especially the list, if the list is actually dynamic, it keeps growing and shrinking, that kind of thing. So how to actually get the last element, right? In other languages, we may have to compute the length of the list first, the length of the array first, right? And then we can actually retrieve the last element by just using the index which is length, subtract 1 or something. But in Python, we can also get the length. In Python, we can also get the length. We can also get the length of the list very easily by using an internal function that's called len. And this len actually takes the list as its input. So if we run it, it's going to tell us the length 4, right? And then we can just use the length, subtract 1 to get to the last element, right? But in Python, there's a more convenient mechanism for us to actually retrieve elements from the back of the array or from the back of the list, right? Which is by using a negative index, right? So if we print countries -1.title. So -1 is going to retrieve the last element inside of that list. So the negative index is going to give us elements from the back of the array. And if I change this -1 to -2, then it's going to retrieve the second from the last. Right? So here printing country is -1. The last element is actually Indian. And then if I sort of convert it into a title case, then it's going to print capital I India. Right. So this is a second way of doing retrieving the elements, the last element, and it's actually a better way of actually sort of retrieving elements from the back of the list. So if I do countries -4, then what's going to happen, right? So -4 is what? -4 is what? So the last element is -1. The second from the last is -2, right? And then Canada is -3, and then -4 is going to be USA, right? So that's indeed USA. So this negative index allows us to retrieve the content from the end of the list, right? And which actually saves us from writing the codes for computing the length of a list and then compute the index by subtracting an integer from the length, right? In other kind of language, you would usually have to do that, right? Get the length first and then subtract the index from the length to get the index for an element that's kind of like counting from the back of the array. And the content retrieved from the list, in our case, in our example, which is pretty much just a string, right? It can be used inside any other codes that can take a string. For example, if we want to compose a longer string by using those shorter strings retrieved from the list, we can just do that by, so suppose we want to compose a message equals to countries 1, which is Canada, right? We can sort of concatenate is to the north of, and then plus countries 0, and again plus a period, right? And if we want to print the message, we can print the message. So Canada is to the north of USA, period. So, and if we would like to actually modify the content of a particular element inside a list, say we want to capitalize the first character of the last element, we can just use our retrieved element as a ordinary variable, countries -1. So here we are actually retrieving the content of the last element, right? And then we are actually assigning values to it. We are assigning values to it. The values that we want to assign to it is actually countries -1 title, the title case, right? So now if I run the whole script, the last element is going to have title case with I capitalized, right? So that's using sort of the accessing using the position and then accessing the one element of the list on the left side of the assignment operator. It's not just on the right side of the assigning operator. So that's accessing different elements inside of a list. So unlike the array in some other languages, the list in Python is actually dynamic, which means that we can add elements to it and remove elements from it after the list has been created. And one of the data structures that are used widely is called a stack. using the list as a stack. A stack allows us to add or remove elements from the same end of an array. So it follows the last in first out, or last in first out. It's actually so it's last in first out, or LIFO. So the elements must be added or removed from one end of the array, from the same end of it, from the same end of the array. The access pattern is called last in first out. We can use the Python list as a stack. If we would like to add elements to the end of the list, we can just use the append method on the list. So if we countries.append, so if we would like to add France, add a new country to the countries list. If I run this thing, then I'm gonna have one more elements that is appended to the end of the list. And what I was saying is that for stack, the elements are added and removed from the same end, right? So if I want to sort of remove an element, I cannot sort of do that at an arbitrary position. I must do that at the end of the list also, right? So if I want to use it as a stack, I can use, if I want to remove the last element from the list, I can do countries.pop. The pop is also a method that's defined on a list object, right? And this pop method is going to return the element that has just been removed. So if I do this assignment, last country is going to give me France. Last country is going to give me France. So append and pop allows us to sort of use the list as a stack. Right? So one of the ways for building up a list dynamically is just to start with an empty list. Say we start with an empty list that's called states. An empty list is just an empty pair of square bracket, and then we can just gradually add or append more and more states into this list, right? So states is a stack, and we can append more states into it, right? Here we have added 3 states into this particular stack. And if we would like to dynamically remove the states, we can just keep popping them one by one until the list is empty. You can just pop, right? So after the first pop, the states is gonna become California and Colorado. Florida has been removed, right? Because that's the end. That's the last state, right? And then after the second pop, Colorado is gonna be removed. We have just California left, right? And then if I keep doing the pop, then states are gonna become empty, right? If I still keeps popping the list, then it's gonna give me error. It's gonna pop from empty list. It's gonna tell me there's nothing to pop anymore. So this one is incorrect, right? That's using the list as a stack. You're adding elements and retrieving elements or removing elements from the same end of the list. Right? And the list can also be used as a queue. A queue is different from the stack. It's also a very popular data structure, but it's different from the stack. In a stack, the elements are added and removed from the same end, so it follows the last in first out access pattern. But in a queue, the elements are added at one end and removed from the other end, so it follows the first in first out access pattern. Or FI, FO. So to use the list as a queue, we can still append elements at the end of the list. But when we actually remove elements, we must remove it from the beginning of the list or the head of the list, right? So if we run this code for now, so states has California, Colorado, Florida, right? When it works as a stack, we have to sort of remove elements from the back. Remove Florida first, and then Colorado, and then California, right? But now if states works as a queue, then we must remove elements from the head. So we must remove California first, and then Colorado, and then Florida, right? So how do we do that? We can still use the pop method, but with one optional input parameter. And if we want to remove from the head of the list, then this input parameter must be 0. So if we sort of do a states.pop 0, then California is going to disappear, right? And the returned value, first state, is going to be used for storing the element that you just removed. And then we can just keep doing that. Then this time it's going to remove Colorado. We have just Florida left in it, right? Now Florida are also being removed. So every time if we actually pop from the 0th position, then the list can be used as a queue. In practice, if we have lots of elements in the list, using the list as a queue is actually not very efficient, because every time we pop an element from the head, from the beginning of the list, all the remaining elements inside of the list must be shifted forward by one position, which can take a lot of time if the list is very long, like millions of elements, that kind of thing, right? If that's the case, Python actually provides a much more efficient alternative for using the list as a queue. It actually provides a much more efficient alternative, right? And this alternative is called a deque, or double-ended queue. And in order to actually use the deque, we must import it from an outside module called collections. And the syntax for importing something is to use the keyword from and import keywords. So in practice, what people usually do is to put any kind of import statements at the beginning of your source code. So here we want to import from a module that's called collections. From collections, import the class that's called deque. Deque is just a double-ended queue. And that's sort of the syntax for importing something that's outside of the core of Python, right? And collections is a name for that particular module. And the class that we want to import is called deque, right? And once we have added this particular line, then the class deque is available to us inside of our own source code. So how do we actually use it, right? How do we actually use it? We have the deque class available, right? So now we can use it to create our queue for the states. So let's call it states 1. States 1. And states 1 equals to deque. Let's give it some kind of initialization value, California. It can be just you can just do it as a like this kind of thing, right? Then you are gonna create a deque with an empty list, right? But if you actually put something into it, it's also gonna work. It's also gonna work. And then once we have created this deque, we can append to it. Right. So now we have a deque that has these 3 elements in it. By default, you won't be able to see states 1 inside of the variable explorer. The reason is that the variable explorer does not know how to actually display a data structure that's a deque, right? But if you would like to see those variables, nevertheless, there's a button here, this gear button, which allows you to actually change the settings of the variable explorer. And if you click on it, you're going to see some options. One of the options that's been checked is exclude unsupported data types. So if you uncheck it by click on it, then you're going to see some so states 1 is going to appear here, but you still won't be able to see the content of it, right? And then you have the deque class, right? That's a class type. That's a type. That's a type. It's not a sort of. So here that's the deque. Right? States 1, that's the deque. You won't be able to see the content inside it. So, but if you use a print states 1, you will be able to see the content of the deque. Right, now we have a deque, so how do we actually remove the elements from the head, right? There's another method defined on it. It's called pop left. It's called pop left. Right. So pop left means that I want to remove the elements from the left side of the deque. So if I run it, so at the beginning it's California, Colorado, and Florida. Now California has been removed. We only have Colorado and Florida. Right. Again, if you want to sort of reuse the element that has just been popped, you can assign it. You can assign it to a variable. You can assign the output of the pop left to a variable. So that's called just the first state, right? First state is going to be California here, right? And if you don't want to reuse the popped element, then you can just forget about the assignment, right? And we can actually keep doing that. States 1 dot pop left. So this time it's going to remove Colorado from the queue, right? So Colorado has disappeared, right? And if you do it one more time, then you're left with an empty deque, right? And in practice, deque, this particular data structure is a lot more efficient than the internal list data structure, especially when you are using the list as a queue and the list is very, very long. Right? So that's sort of the better alternative. So that's deque from the collections module. Now let's get back to talk about the list. We have seen how to add and remove elements either at the head or the tail of the list. Can we add or remove elements at an arbitrary position inside the list? So let's talk about inserting and removing at any position. So to insert an element at an arbitrary position, we can use the insert method. Right? This time it's not append anymore. Append can only add elements to the end of the list. But if we want to sort of add elements at an arbitrary position, we must use method. So if we do states.insert, so insert is going to take two input parameters. And the first input specifies the position we want to insert into. So if we want to insert at the head of the list, we can put a 0 in there. And then the second input is actually the content. Right? The content we want to insert into the states list. So if we run it, for now states is an empty list, right? So, but if I run it, we're going to be able to see states being added by, we have one element inside of the states list, right? So if we want to insert another element at position 1, so let's call it Alabama, then this time it's not at 0, right? It's at position 1. Position 1 is going to be, so this is 0's position. Position 1 is going to be behind it, right? So now we have Alaska and Alabama, right? And suppose we want to insert one more. Say insert at position 1 again. So can you guess what's going to be, where California is going to go, right? So this is 0's position, right? And then this is position 1, right? And again, you want to insert at position 1. So let's see what's going to happen. So California is going to appear in the middle. So California is coming to the position 1. And Alabama is being pushed to position 0, 1, 2, to position 2 now. Right? So it involves shifting other elements. So that's insert, right? That's insert. Inserting at a arbitrary position inside of a list, right? But if I do insert, if I do states.insert, suppose I give it like 5, a position 5, right? And then I want to insert Colorado. Is it going to work, right? So does it have a position 5? 0, 1, 2. It only has like a position 2 to the end, right? But if we insert at position 5, if we do this thing, it's going to insert Colorado actually at the end, 0, 1, 2, 3. It's actually at the position 3, right? Because 5 is actually even larger than the length of the existing list already. So it's just going to append the new element to the end of the list. We looked at how to actually remove elements from the head and from the tail, right? From the tail, it's just a pop without any kind of input. From the head, we just give pop a input 0, right? So if we would like to actually remove the elements at any position, at an arbitrary position, right? We can just give it an arbitrary, say states.pop, but this time it's not 0, right? 0 is going to remove from the head. Right? If we do not give it any input, it's going to pop from the end, right? Let's give it a 1, right? If we give it a 1, then states, this is 0, right? This is a 1, so California is going to disappear. Right? California is going to disappear. So Alaska, Alabama, Colorado, California has disappeared, right? And then the returned value from the pop method is going to be stored into this output variable, right? If you don't care about this removed state or something, then you can just leave the output unassigned. So the method pop only allows us to remove elements from specified positions, right? If we know the position of the element we want to remove, then using pop is kind of easy to remove the element. But in some situations, we don't really know the position of the particular element that we want to remove. What we do know is the value that we want to get rid of. So in this kind of situation, what can we do, right? What can we do? Suppose we want to remove the state Alaska, but we don't really know the position of this particular element inside of the list. There is a method for us to actually use. It's called remove, right? So suppose the state we want to remove is stored inside of a variable. That's called toCode. And we put Alaska inside of this variable, right? And then that's the value. And then we can use remove. And remove takes one input, which is the value that we want to remove. And here we can just use toCode. So for now, states has Alaska, Alabama, and Colorado in it, right? If I run this code, states is going to have Alabama and Colorado in it. Alaska has disappeared, right, because it has been removed by this particular method, right? You have to be careful about the case, because when Python tries to match the input value to remove with the existing values inside the list, it's gonna pay attention to the case. So if you actually change Alaska, the capital A to a small case a, then it's not gonna work. So Alaska is still there, right? So it's case sensitive. You have to sort of change it to match the exact case in order for the thing to work. And another thing that we must pay attention to is that this remove method will only remove the first occurrence of the value that's inside of the list. So if there are multiple occurrences of the same value inside the list, and you want to remove all of them, the correct way for doing that is to actually put the remove method call inside of a loop, and that will get rid of all the occurrences of the same value. But we haven't talked about the loop yet, so we will leave that for later. Right? So, but if you want to sort of see the effect, suppose I put 2. Suppose I put like 2. Pinned. So now states has one more Alaska inside of it, right? It has 2 Alaskas. So if I comment out this part of the code first, right click on it and then comment, and then if I run it, so now it has like a Alaska, California, Alabama, Colorado, Alaska again, right? So now if I run it, you sort of see the first Alaska disappeared, but the last Alaska is still there, right? So the remove is just going to remove one of them, right? So if you want to get rid of the second one, you have to run the remove again. You have to run it again, right? So now the second Alaska has disappeared, right? So if you don't really know how many occurrences of the same value inside of a list, you have to use a loop to do that, to do this remove, using a while loop or something, to get rid of all the occurrences. One of the things that may appear very confusing for new Python programmers is how a list is copied. Let's talk about how to copy a list. This part is kind of quite confusing, right? Suppose we just use a simple assignment to assign countries to countries 1. Countries 1. So here we are basically just assigning the list countries, which has 1, 2, 3, 4. I have countries 1 in the variable list already. Let me just clean up the memory space. So to clean up the memory space in the console, I can type %, reset, press enter. Then it's gonna prompt me, once deleted, variables cannot be recovered. Proceed. I say yes. Then everything inside of my variable explorer is gonna disappear, right? So now I can start afresh. So countries, I'm assigning countries to countries 1. Right? It looks like just a copy, right? It looks like just a copy. If I run it, I'm gonna get countries and also countries 1, and they have exactly the same content: USA, Canada, Mexico, India, right? But suppose I change the content. If I change the first element of countries 1, I'm gonna change the first element of it. I'm gonna change it from USA. The current value is USA, right? I'm gonna change it to Italy. If I do that, let's see what's gonna happen. The first element in countries 1 changed to Italy now, right? But the unexpected behavior is that in countries, the first element is also changed to Italy. It's no longer USA anymore, right? So here I only changed the first element in countries 1. I didn't actually even touch countries, right? But nevertheless, countries has been changed. The content inside the countries has been changed. If you know the distinctions between the so-called a deep copy and a shallow copy, then you will notice that this assignment is actually a shallow copy. So a shallow copy means what? It means that it does not actually duplicate all the actual contents of the list countries into a separate memory space and then assign countries 1 to that new allocated memory space. It merely just creates another alias that's called countries 1, and then just link this new alias to the same memory space that is allocated for countries. So both countries and countries 1 are just the 2 different handles that's pointing to the same memory space. So changing the contents in countries 1 is actually the same as changing the countries or changing the contents in countries, because you are manipulating the same memory space using just the 2 different handles. So if we would like to actually make a deep copy of a list, a deep copy means what? A deep copy means that a new memory space is allocated, and then the content of the original list country is then duplicated 1 bit by 1 bit, is then duplicated into this new memory space, right? And then the new name countries 1 is assigned to pointing to that newly allocated memory space. That's called a deep copy, right? If we want a deep copy, if we really want a deep copy, so how do we actually change the code, right? So suppose countries 2 equals to countries. So how do we actually change the code, right? We change the code in this way, right? This colon that's inside of the square bracket is something that's called a range operator. A range operator is just this colon, right? It's this colon, right? So now if we run it, we're gonna get one more list that's countries 2, right? And for now, it's having exactly the same value as countries: Italy, Canada, Mexico, India, right? But now suppose I change the first element in countries 2 back to USA, for example, right? And then we run it again. So now countries 2, the first element has been changed to USA, and countries 1, both of them still has the first element fixed at Italy, right? So changing the memory space in countries 2 is not going to affect the memory space that's pointed to by countries and countries 1, because those are 2 separate memory spaces. So that's one of the things that we have to pay attention to when working on those kind of composite data structures inside of a Python. This is a shallow copy, but this is actually a deep copy, right? This thing. That's called a range operator. So the range operator basically allows us to actually select certain portions inside of a list. So now let's look at how to selecting elements by using the range operator, right? So let's try to create a longer list. For now, all the lists are too short. Let's create a longer list so that we can sort of see the effects more clearly with the range operator. So let's try to create another list called numbers. Numbers equals to list range 10. So the function range here, it's an internal function of Python, right? This range function will create a sequence of numbers that goes from 0 to 9, actually. It's not from 1 to 10. It's going from 0 to 9. So if you don't believe me, just run the code. You'll be able to see inside the numbers, this particular variable, the numbers are going from 0 to 10, right? 0 to 9, it's not to 10, right? So 10 is not included. 10 is actually excluded, right? The starting index of 0 is included, but the ending number 10 is actually excluded. So this range function is going to create the return type in Python 3 is called an iterator. In Python 2.7, for example, the return type is directly a list, right? But in Python 3, they have changed the return type to an iterator type. We haven't talked about what exactly is an iterator, right? We'll talk about that in later videos. But in order to actually convert that back into a list, we can use this internal function that's called a list. And this internal function list is going to convert the iterator that's returned by the range back into a list. So numbers is going to be a list. So this number is going to have a type of list, right? So now we have 10 numbers that we can work with. Now suppose we would like to select the elements or the numbers from the 0th position to the 5th position, right? So how are we going to do that, right? So let's call it numbers 1 equals to numbers. We're going to use the range operator inside the square bracket, 0 to 5, right? Let's run it and see what's going to happen. So now numbers 1 is also a list. How many elements inside it? It's 5. It's 5 elements inside it, right? Why it's 5 elements, right? Why it's 5 elements? If you use the ending index, subtract the starting index, right? 5 subtract 0, that's 5, right? So it's going to give you 5 elements. It's a list of length 5. And then what's going to be the elements that's inside of it, right? So what I specified is the starting index is 0, right? The ending index is 5. So 0, that's 0 position. That's the first position. So 0, first, second position, third position, fourth position, and then 5th position. But the number that's at the 5th position, which is the integer 5, is not really included in the selection. You don't see 5 in numbers 1. You only see 4. Right? The first index, the starting index 0, is included. See? The starting index 0, 0th position has the integer 0, right? And 0 is included in the selection. But the ending index 5, which is the 5th position, 0, 1, 2, 3, 4, 5, the 5th position is not included in the selection. Right? This is something that we need to pay special attention to. right? This is the behavior that may not be sort of might be unexpected behavior if you are a MATLAB user, right? If you have been using MATLAB or Fortran, this kind of behavior is sort of unexpected, right? So Python is actually inclusive for the starting index, but exclusive for the ending index, right? So that's something that we need to actually just remember. It's something that we need to memorize. It's inclusive for the starting index, but exclusive for the ending index. So the ending index is not going to be the content corresponding to the ending index is not going to be included inside of the selection, right? And if the starting index is actually 0, then this index can be neglected. We can just omit. We can just omit the starting index, right? So numbers 2 is going to be identical to numbers 1, and both syntax works. So if the starting index is 0, then you can just omit it, right? So suppose we would like to select the last 5 elements. So how are we going to do that, right? How can we actually do that? Suppose we want to select the last 5 elements. We can use the negative index inside of the range operator, right? So -5 colon. So here it looks like I'm missing something here, right? Right. I want the last 5 elements, but what's actually the ending index here? If the ending index is 1 past the last element inside of the list, then you can ignore it. You can neglect it. Right. So this syntax is gonna give me from the -5th index to the end of the list. So number 3 is gonna be -5th element. The starting index is gonna be inclusive, right? So this 9 is actually -1. 8 is -2. 7 is gonna have a position of -3. 6 has position -4, and 5 has position -5. So -5 is going to be included, so in the selection. So number 3, the first number in number 3 is going to be 5, right? And then because the ending index is not specified, so it's going to default to the last element inside of the list. So the last element inside the list is 9. That's exactly 1, 2, 3, 4, 5 elements. So if we would like to select all the odd numbers from this list, right? This list has both even numbers and odd numbers, right? Suppose we would like to select all the odd numbers. So how can we do that, right? How can we actually do that? Let's do numbers 4. So how can we actually use the range operator to select all the odd numbers, right? So we're going to start with position 1. Because position 0 has a number 0. 0 is actually an even number. So let's skip that. We're going to start from position 1. So the starting index is going to be 1, right? And then the ending index is going to be what? The ending index is going to be sort of the 1 past the last element inside of the list, right? So if that's the case, we can omit the ending index, right? But then we don't want to sort of select all the elements from the first position to the last position. We don't want to select. We can specify a stride. So here I have omitted the ending index here. It should have some value in here, right? But because it's the last element of the list, so I can just omit it, right? And then if I can add another colon, and after this another colon, the second colon, I can specify the stride. Basically, the number of elements I can actually sort of skip, right? The stride, let's give it a 2. The reason that I want to sort of have a stride of 2 is because we want to select every other element inside of this list, right? And if we run this code, number 4 is going to have all the odd numbers, 1, 3, 5, 7, 9, right? So if by using this kind of syntax, you can specify a stride. So the number of elements you can skip is the stride subtract 1, right? So that's how to select elements. And one last thing we want to talk about is actually sorting. So a list is a sequence of elements. If we have a sequence, then we can sort that sequence. In Python, there are two basic approaches for sorting a list. The first approach is just to use the sort method defined on the list object. So if I have countries, right, it's a list of countries, Italy, Canada, Mexico, India, right? I can call the sort method on it. And if I run this code, so now countries are going to be sorted. It's sorted according to the alphabetic order. So Canada, because it starts with a C, so it's ranked in front of India because it starts with the I, right? And then India is ranked in front of Italy, even though the first character is both I, but N is ranked in front of T. So that's why India is ranked in front of Italy. So by default, it's going to sort according to the alphabetic order, right? If we would like to sort in reverse alphabetic order, the sort function actually has an optional input. So not sort function, the sort method. It has an optional input that's called reverse. We can set the reverse value to true. By default, it's going to be false, right? So it's going to sort in alphabetically ascending order. But if I specify reverse equals to true, then it's going to sort according to the reverse alphabetic order. So Canada becomes the last element. And then India. Mexico becomes the first element. Mexico, Italy, India, and Canada. So reverse equals to true allows you to actually sort in a reversed alphabetic order. And if the list itself is a sequence of numbers, right, then it's going to sort according to the numerical order, right? But the problem with the sort method on the list is that it's going to destroy the original ordering of that particular list. So the original ordering from the countries list is kind of unclear to me now. Right? Do you still remember what's actually the original ordering of those 4 countries? Right? So you have lost that information. And if that information is of some kind of importance, it might be an undesirable effect to actually call the sort method on that list, because it's going to destroy the ordering in the original list, right? So one of the ways to solve this kind of problem is just to make a deep copy, of the original list, and then sort that copy instead of the original list, right? But that's gonna sort of create some kind of a overhead, right? And if the only purpose for sorting the list is just for printing purposes, if you want to display the sorted list instead of in the original order, right, just for displaying purposes, then it might be unnecessary to actually just waste a big piece of memory to make a deep copy of a very big list. And there is another approach to sort, which is use the sorted function. It's not a method; it's a function. So it's so if I just do a print sorted, and then I can do that, right? So it's going to be Canada, India, Italy, Mexico. It's sorted in the alphabetic order, right? The screen display is going to be sorted, right? But if we look at the content of countries, the list itself, it's still Mexico, Italy, India, and Canada. So the list itself is not changed in any way, but the displayed result has been changed. And if you actually choose to actually store the output of the sorted function, you can also do that. So countries, let's call it 3 equals to sorted countries, right? So countries 3 is going to be used to store the sorted version of countries, right? And it's going to be inside of a new memory space, a new piece of memory space that's newly allocated, right? So in some sense, it's still creating a deep copy, right? Except that all the elements inside of this deep copy has all been rearranged into the sorted list, right? So now countries 3 has Canada, Italy, India, and Mexico sort of in the sorted order, right? And this sorted function also takes an optional input that's reverse equals to true, right? If you want to change the sorting behavior from ascending to descending orders, right? And if you wanna sort of sort in a descending order, there's another way of doing that. First you can call the sorted function so that you can or the sort method without the reverse equals to true, right? Without the optional input, then it's gonna sort in the ascending order, right? And then let's use countries 3. And then you can call reverse. You can call the reverse method on that list, right? If the list is being sorted in the ascending order, calling the reverse method on it is gonna change the ordering to the descending order. So now it's Mexico, Italy, India, and Canada. It's the descending order for countries 3. And that's how you can actually use the sort function, use the sorted function and the sort method and the reverse method.